Okay, let's continue. My memory card get full, so the video was truncated last video, and we're gonna continue here. We're gonna solve this problem here. Okay, now to find out the minimum thickness of this nuts, we're gonna set the shear stress of nut. Shear stress of nut equal to, so the shear stress of the nut equal to the tensile stress of bolt, oh, not stress, force, shear force of nut equal to tensile force of the bolt. So it's like you pull the nut away, the shear force in the nut should equal to the tensile force of the bolt. So we're gonna set like that. Okay, so the shear force of the nut, that is equal to the circumference. Now this is D here. We find out the shear area times shear stress, shear area times shear strength, and the shear area is going to be pi d. Now if you have a thickness over there, pi d, let's say this t, thickness is t here, that's a thickness. So that's a shear area, pi d times t, this should be equal to shear area. But wait, and when we make the threads, it's not precisely a triangle like that. It's not precisely a triangle like that. It actually, you can make that. It's actually somehow like this, somehow like this. So when two threads get engaged, this is a T here, and this T not 100% is engaged, only 75% that is engaged. So the shear area so the shear area and it's equal to pi d circumference times 75% of the thickness that is engaged. And then how about the shear strength? How about the shear strength? The shear strength, we use proof strength, and the shear proof strength is equal to 58% of proof strength. Shear proof strength is equal to 58% of proof strength. So to continue this formula here, we have pi d, that's a major diameter, 0.75 t, that's also considered the major diameter, and 0.75 t engages this shear area, and times 0.58 proof strength, SP of nut, SP of nut, okay? And that's going to be the shear force. And this should equal to the tensile force of, should equal to the tensile force of the bolt, which is equal to the tensile area times the proof strength, So this is this simple. This is proof strength of bolt, right? That's a because we know the definition of stress is equal to force divided by area. So force is equal to stress, which in this case is strength, times area. So that's where we get this formula here. Now in this formula here, it's gonna be similar to this one here, and the only thing that change will be this will change. Okay, when you solve a problem, and certainly this will change. And those numbers, pi is not going to change, 0.75 is not going to change, 0.58 is not going to change. You're going to plug in those numbers. Okay, this is the formula here. So now we're going to plug in the numbers here. Pi, let's use 3.14. D is 10 millimeter in our case, and 0.75, and T we don't know. We want to find out, and 0.58, and SP of nut, which is here 310, and tensile area, which is this one here, AT 58 times 380. Okay, so you know T is equal to 558 times 380 divided by all those 3.14 times 10 times 0.75 times 0.58 times 310. Be careful in your calculation, okay? You gotta use this divided by this bunch, and then what you find out, this number here is I calculated somewhere, and this one is 5.2 millimeter. So the minimum, that's the minimum thickness of the nut. Okay, now how many threads that must be engaged? Number of threads. So the thickness is equal to number of threads times pitch. And in our case, the pitch we find out, which is this one here. This will be the pitch. We find out where we find out. Oh, here. This is a pitch. So pitch is 1.5 millimeter. So number of threads is equal to thickness divided by pitch. Now in standards, number of threads, that's metric. Standard number of threads is equal to thickness times pitch, because the definition of pitch is different. So pay attention to that. Okay? Pay attention to that. And in our case, you find out that number of threads, and you just plug in threads is equal to thickness is 5.2, pitch is 1.5, and you find out 3.5. That's the minimum number of threads that you have to engage to prevent stripping. Now this time I'm gonna give you some homework, okay? Not homework, assignment. I'm gonna give you some assignment. And the assignments, that will be page 468, 10, 33, 10, 38, 10, 39, 10, 40, 10, 40. 4 problems. Give it a try. 4 problems, okay? And give it a try and let me know if there's a problem. Thank you.